Okay, hi guys. So in this lecture as well, we'll be continuing on seeing degrees of freedom for a triatomic gas. Okay, so for a triatomic gas, we can see that as n equals to 3, so total degrees of freedom would be nothing but 3n or 9. Okay, so suppose if the triatomic gas is linear, then we can write that transitional degree of freedom, total number of transitional degree of freedom would be 9. Rotational degrees of freedom would be 2, and vibrational degrees of freedom would be remaining, which is 4. Okay, and for non-linear gas, non-linear triatomic gas, we can see that translational degrees of freedom would be 3, rotational degrees of freedom would be also 3, and vibrational degrees of freedom would be 3. Okay, so let's now see the CVM and CPM values for linear triatomic gas. So for linear triatomic gas, we can write that first at room temperature. So at room temperature, we don't consider the vibrational degrees of freedom. Okay, so CVM would be 3 by 2R, which is 3 is the number of transitional degrees of freedom, 2R by 2, 2 is the number of rotational degrees of freedom plus no vibrational degrees of freedom. Okay, because this is at room temperature, so we don't consider vibrational degrees of freedom at room temperature. So CVM for linear triatomic gas at room temperature would be 5R by 2. Okay, and gamma can be calculated, and it would come out to be 7 by 5. Okay, second, if we see very high temperature, so for very high temperature we will also be considering vibrational degrees of freedom. So CVM would come out to be 3R by 2. 3 is obviously for translational degrees of freedom, 2R by 2, 2 is for rotational degrees of freedom, and remaining 4 are for vibrational degrees of freedom. So it would be 3R by 2 plus 5R, so it would be 13R by 2. Okay, and gamma can also be calculated, that should come out to be 15 by 13. Let's see for now non-linear gas. Non-linear triatomic gas. Okay, so for non-linear triatomic gas, first at room temperature, we can have total degrees of freedom as, or rather if we calculate the value of CVM, it would be 3R by 2 plus 3R by 2, which is, this is for translational and this is for rotational, and we won't be considering any vibrational because it is at room temperature. So CVM would be 3R, so gamma can be calculated from the same, it should come out to be 4 by 3. Secondly, if we have high temperature, so at high temperature we also take into consideration the vibrational degrees of freedom. So CVM would be 3R by 2 plus 3R by 2 plus 3R, so it should be 6R, and gamma value should come out to be 7 by 6. Okay, now let's define the formula for calculating degrees of freedom or value of CVM rather. So for polyatomic linear gas, we can write that at very high temperature, where vibrational degrees of freedom is active, it would be CVM equals to 3R by 2 plus 2R by 2 plus 3N minus 5R. 3N is the total number of degrees of freedom, minus 5 because of 3 of translational degrees and 2 of rotational degrees. So 3 plus 2 is 5. So 3N minus 5 is the remaining degrees of freedom for vibration. So this is for polyatomic linear gas. Now let's see for polyatomic non-linear gas. So for polyatomic non-linear gas, again we are considering very high temperature. Why? So as to accommodate vibrational degrees of freedom as well. So very high temperature, we would be having CVM as, this is CVM, better clarity, CVM would be again 3R by 2 plus 3R by 2 as well for rotational, and remaining would be 3N minus 3 plus 3, which is 6 transition or vibrational degrees of freedom. Okay, so this is the translational, this is rotational, and this is vibrational. By the way, I actually forgot to discuss the CVM value for monatomic gas, so we'll just discuss that. So for monatomic gas, we know that N equals to 1, so degrees of freedom would be 3N, which would be 3, and this is total degrees of freedom. Total degrees of freedom would be 3N, which would be 3. Okay, so here all the 3 would be translational degrees of freedom. Okay, similarly CVM can be calculated for the same. So with this we come to the end of this lecture and the end of this series of video lectures on physical chemistry. Okay, so I hope you enjoyed this video lecture series, and we'll meet in some other video lecture series. So till then, good luck and goodbye.